Okay, so let's do practice quiz 4, 3b. It says, first show that y1 is a solution, then use reduction of order to find a second solution for this differential equation here. So to show y1's a solution, let's find the first and second derivative. So doing that, we get then, okay, so taking derivative of 1 over x, I'm writing it as x and minus 1, so you bring the minus 1 in front, subtract 1 from the power, so it'll be minus x and minus 2. Then for second derivative, take the minus 2 in front, then it'll become just positive 2, subtract 1, minus 3. So let's substitute these guys now into the differential equation and place a y, putting the y1 prime and y1 double prime and y1. So doing that, we get then, so making a substitution, so it'll be 2x squared times y1 double prime, which is 2x and minus 3, plus x times y1 prime, which is negative x to the minus 2, then minus 3 times y1, which is x and minus 1. So this should equal 0. So multiplying this in here, this will be 4x to minus 1, this will be minus x to minus 1, this will be minus 3x to minus 1. So it looks like it's going to check out here. So note here. So reduces to this and it just becomes 0. So we've shown then that y1 is indeed a solution of this differential equation. Now let's use reduction of order to find a second solution. So let me write the reduction of order formula here. Okay, so here's the reduction of order, or theorem 6. It says if y1 is a solution of this differential equation, then y2 equal to y1 times integral y1 to the minus 2e to the minus integral of p of x dx. This guy is also a solution. Okay, so we have to identify our p in our case. But notice this differential equation here, the coefficient in front of the y double prime is 1. So we're going to have to divide everything by x squared here. So let's do that. Okay, so taking our original differential equation up here, dividing everything by 2x squared to get the coefficient in front of the y double prime to be 1 here. So doing that, we'll have then, simplifying this will be y double prime plus 1 over 2x y prime minus 3 over 2x squared y equals 0. So it looks like the p is going to equal to the 1 over 2x here. Okay, so our p of x is 1 over 2x. Alright, so I'm out of space here, so let me erase a few things and we'll keep going. So summarizing, we have this, we have our p of x is 1 over 2x, or y1 is 1 over x, or x to the minus 1, and we can find our y2 by using this formula here. So let's plug into this formula with the p being 1 over 2x, and the y1 equaling to x to the minus 1. So doing that, we get then, okay, so making the substitutions, so we have y1 is x to the minus 1, so you have x to the minus 1 here, then y1 to the minus 2 here, and p of x 1 over 2x here. Okay, so let's simplify this a bit. So this is going to become just x squared here. Let me pull out the 1/2 of inside the integral here. So doing that, we get then, so we get this then, and the integral of 1 over x would be, should be dx after this, will be ln of x here. Okay, so let me do that over here. Okay, so integrating 1 over x, it's ln of x. I guess it would be plus c also here, but I'm just going to choose the c to be 0 for the time being. Okay, and let's bring this negative 1/2 now up on the exponent on the x. So doing that, we get then, we get this, and now the e and the ln will cross off here. So doing that, we get then, we get this, and then we can add the exponent, so 2 minus 1/2 would be 3/2. So right over here. Okay, so we get then y2 equals x to minus 1 times integral x to 3/2 dx. So integrating x to 3/2, adding 1 to the power, we get this. Plus c, I'm going to choose the c to be 0. So we get then, x minus 1 times 2/5 x to the 5/2. So adding the exponents here, we get then, okay, so we'll have then x to the minus 1 plus 5 halves. 1 is at 2 over 2, so it's become 3 halves here. So it'll be 2/5 times x to the 3 halves. So this will be a solution also. But as I mentioned in the last video, we can multiply a solution by a constant and it's still a solution. So let's note that here. So in the last video we mentioned that if you take a solution and multiply it by a constant, it will also be a solution of that differential equation. The differential equation has to equal 0, which it is in our case. Okay, so in particular then you can choose this c value to be 5 halves to cancel with this fraction in front. So our y3 solution, we could just say, is x at 3 halves. So you can just get rid of the number in front there. So x at 3 halves power is our second solution. Okay, this is actually fine up here too if you want to leave it like that, but it just looks nicer like this. Either way is fine, I guess. Okay, so we found our second solution. So we're done with the question, so let's leave it there.